CubeSats. They've been around for a while now. The domain of universities and institutions wanting to teach and gain experience in space. They're low cost, light, and very adaptable. Not only that, but they're also easy to send into orbit. Now, business is eyeing off these microsatellites with big plans for the future. The traditional satellite is an industrial and technological marvel. Designed and built from the ground up for a specific purpose with a long life expectancy, some communications and global positioning satellites are built on an off-the-shelf platform design to help alleviate costs. Launching them into orbit, however, is no easy feat. Weighing as much as 50 tons, they have to be placed in a geosynchronous or high polar orbit, which requires expensive launch facilities. The CubeSatellite, or microsatellite, devised as a training and development tool for university students, has now taken on a life of its own as a low-cost alternative to the conventional satellites in particular roles and for new purposes not previously considered.
A CubeSat is a nanosatellite basically in a box size. The standard dimensions of a CubeSat would be 10 by 10 by 10 centimeters, and you can have multiples of that unit. So you could have a 3-unit CubeSat, for instance, 10 by 10 by 30 centimeters, and all of the satellite equipment has to fit inside that box. The origin of CubeSats goes back over 10 years. In the US, university professors were looking for ways to allow their students to essentially build and fly satellite hardware during their degree courses. And so that was envisaged as a very low-cost way for universities to get their students well educated in the engineering skill.
University student teams from around Europe have been busy in the last months making the final preparations for ASIO, the European Student Earth Orbiter. ASIO is preparing the space workforce of tomorrow. The student teams designed, constructed and tested the essential parts for the mission.
During its whole project life cycle, ASIO engaged several hundred students, and already before launch we can say that it achieved all its main educational objectives.
Launched aboard a SpaceX small satellite-dedicated Falcon 9, ASIO was released into a polar orbit. Aboard the satellite there is a radio amateur communication system by the University of Surrey and AMSAT UK in the United Kingdom. This enables ASIO to transmit real-time data to schools and universities for science and engineering lessons.
I participated in the LMP project. It is a bit a personal project for me because there is a component which I have in the design, and I wrote my thesis from this component.
I've been involved in the development and testing phases of the power distribution unit of the ASIO satellites. It's an amazing feeling that your device will go up into space and it's ready, it's working well, and I'm so happy.
ASIO is a complex system, and in the end I think it was challenging activity for all the payload teams. We had the chance to stay with them. We had the chance to teach them a few things that typically are not so common in academia.
ASIO gave us the competence to actually build any scientific instruments here in the observatory. it gave us both the competence and also the connections with ESA, and we learned a lot from the projects in order to develop our further missions.
There's been some evidence that lightning produces gamma rays, and this is really the first satellite that's going to go out and investigate if and how and where and everything associated with gamma rays coming from lightning. There's been evidence, and others have seen this, but again, there's never been a satellite dedicated looking down at Earth for these terrestrial gamma ray bursts.
We want to make artificial signals similar to lightning and see what the board does, make sure it's filtering those signals the way we want.
We're going to put it into HDL code and then get it through this chip.
One of the tenets of the CubeSat program is to involve undergraduate students at all levels, from design to building to some of the theory, data acquisition, every aspect of this. So we're really training here the next generation of space scientists, of satellite engineers. As soon as the launch goes up and they know they're a part of that satellite and data's coming in, I mean, that'll be with them throughout their life.
Where else could CubeSats be applied? A major space mission to Mars, InSight, was a perfect opportunity to test out some new technology.
Liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine ignites and generates more than 860,000 pounds of thrust.
Flying with the InSight spacecraft to Mars were two CubeSats. Called Mars Cube 1 or MARCO, they were a technology demonstrator and the first use of miniature modular CubeSat spacecraft design in deep space. The pair of briefcase-sized spacecraft, MARCO A and B, were launched on the same rocket as InSight and traveled independently of the main craft. They carried a number of communication and navigation flight experiments. Although NASA emphasized the experimental nature of the CubeSats before the InSight landing, the MARCO spacecraft performed as intended, receiving the UHF telemetry from InSight during its entry, descent, and landing phase, and rebroadcasting it at X-band frequencies received by NASA's Deep Space Network. This vindicated CubeSats as another tool in the exploration of deep space. To top it off, MARCO B managed to take a photo of Mars and transmit it back to Earth as it passed by the planet. The rush to exploit CubeSats is on. Scientists and engineers have begun designing, building, and launching various designs for specific missions and for testing new technologies in space. Rocket launching companies have been quick to respond, developing and flying dedicated launches for the emerging small satellites market. SpaceX and ESA's Vega launchers are among these companies, while the Electron from Rocket Labs has already begun flying commercial CubeSat launches and is planning a monthly service.
My involvement goes back 10 years from when I was working in the education office at ESA. So indeed, I was responsible for managing university CubeSat projects that we would then later fly on the maiden flight of the Vega launch. We had 7 CubeSats that flew on the Vega maiden flight, and actually many students were involved in those projects, and they went on to graduate, and many of them formed their own spin-off companies, which now forms the basis of the CubeSat industry today. What we're seeing is that the same technologies that are being exploited terrestrially for aerial drones are also being exploited by CubeSats. So I like to think that that same technology will enable CubeSats to become the autonomous drones of the space domain. With the capability of CubeSats to become autonomous space drones, they will have the performance to be able to perform autonomous navigation, close proximity operations around other target objects, and also be able to fly in swarm formations. So these are very advanced architectures. We might also see them being able to perform autonomous rendezvous and docking together, forming building blocks to build up larger structures in space in the future. When we do the CubeSat projects, of course, the standard engineering approach combined with the access to ESA facilities and technical know-how gives an added value to ESA member states to ensure that we maximize the probability of mission success within the tight financial constraints of each project. So far, we've flown one technology CubeSat in orbit, GOMX-3. That mission has been very successful. It's recently re-entered the atmosphere, so the mission has been completed successfully. Now we are preparing to fly another CubeSat called Carmen. It's designed to demonstrate re-entry technologies, a very exciting and challenging project. And beyond that, we have another 4 technology CubeSats in development, and we're already talking to our member states about starting many new projects in the future for these technology demonstrations.
The use of microsatellites for commercial and industrial purposes is a growing field of interest, as is the concept of the Internet of Things. One company has combined the two into what may become the next great technological revolution. Alongside household names like Microsoft, Google, and SpaceX, you may soon be adding fleet to the list.
So Internet of Things is a concept that probably started 5 to 10 years ago. You know, people were talking about this. There are 25 billion devices coming online in the net. It's the fourth industrial revolution. Everything will be connected. It's going to change our lives. I kind of separate the concept in two. The smart cities, so when our life will change into buildings, you know, your Fitbit connected to your fridge and your car driving itself, and the smart fridges, and smart traffic lights, and so forth. And also smart industry. So what happened in remote areas, in a big farm or in a big oil and gas company, a big mining, that's a heavy industrial revolution. So Internet of Things is the idea that we are kind of changing the way we operate. We have spent 40 years connecting people and, you know, bringing computer inside factories, and suddenly everyone has got a computer that cannot live without it. You know, if there's a day you cannot use a computer, you go home because what am I supposed to do? So in the next 40 years, things will change the industry in the same way the computer did. So imagine a big farm, suddenly everything will be connected, you know, from the soil to the literally soil, you know, content to animal tracking, weather station, thousands of sensors that we allow the farmer to literally understand so much of the way they operate that we will solve the biggest problem on Earth, you know, water leakages and drought and so forth. But that goes into, you know, transport and logistics, not measuring pallets and fruits traveling all over the world. I think we waste 60% of our food in supply chain. So there are big changes happening, and this is all about little sensors being connected. The problem is that this big industry that I'm mentioning, they have no 3G. I mean, 3G, 4G, even 5G covers the population, but 95% of the world is unconnected. And this is where our farms are, where our mining and oil and gas company are, where the shipping containers are. So it's a kind of a problem that terrestrial infrastructure cannot solve. And well, we got space, or we solve it from space.
The potential for a constellation or swarms of CubeSats to become powerful research and communication tools is now starting to be explored. The ability to track almost anything across the planet is now a reality. The possibilities seem almost endless.
Internet of Things is interesting because with one satellite in LEO, so low Earth orbit, you cover almost every side of the planet. And customers see you once a day. It's not much. You know, it's not really good for high-speed internet or talking Skype or checking YouTube, but it's great, you know, for a valve, or a soil moisture sensor, or a cow. You don't want to know where a cow is every single minute of your day. Probably you do, but once a day is perfect for LEO. But when you reach 100, or for us it's 100, it probably will be even less, the latency is so good that you can actually take all some, you know, high pressure emergency applications like safety and security, in which you want to send the data and grab it straight away and send it to the customer straight away. But the good things of Internet of Things is that you launch one satellite and then you're in operation. You can serve everything now. So we had launched 4 satellites last year. It was a great journey of fleet. You know, for a startup, we launched them in 24 days. 2 with Rocket Lab was first Rocket Lab launch of nanosatellites was commercial. So it was literally like, what is going to happen here? And then of course SpaceX and PSLV. But the first satellites we built was almost 1 year. The second one 2 months. When we launched with Rocket Lab, by the time we start building the satellites, to the time we booked the flights and the time we were in space, was 4 weeks. You know, so There's a big revolution also on the launcher side, that can put us in space quite fast.
This startup company seems to have hit the nail on the head. Low-cost terrestrial sensors can be hooked up to almost anything, and their status uploaded to the CubeSats for transmission to the clients via the net.
I mean, the people that are booking these sensors, they come from the biggest oil and gas company in the world with all the farms in South America. This is big customer. So we are entering a phase in which, as most startups are starting so little, is having massive customer impact. That satellite company that operates for $1 billion in many, many years don't have. So it's time to see at these satellites and understand it's not a game anymore. This is going to be $1 billion companies very, very fast. So it's quite exciting.
This system could increase efficiencies and save waste across the globe.
Earth needs help. Earth needs monitoring, Earth needs efficiency, Earth needs water to be saved, and food to be not wasted, and people to be safe. So millions of sensors is going to change the world forever. It's going to be billions. When we started Fleet, we started with a dream of connecting the entire world and millions of devices. We call it 1F. It's our first constellation, and for us 2F is going to be the moon, and 3F is going to be Mars.
The potential for space exploration is exciting. Quick and efficient data networks dispatched to the Moon, Mars, and beyond, or even swarms of CubeSats surrounding an asteroid or a spacecraft during rendezvous, sending back data and video. The scope is limitless.
Imagine you can have a constellation to track every robot and things just to make sure where they are, and this is just the beginning. And the reality is that when the big entrepreneur will go to Mars, they will put so many things, and you want to make sure they're tracked, and it's a complicated exercise. And a CubeSat, it's a way to go there fast. When you need to move a big satellite to Mars, it takes a long time. And you launch a storm of bees, eventually they will get there. But eventually we'll go there, and we will have to do the same. We will have to have big responsibility when we start conquering the other planets, monitoring what happened. I think, it's going to be fleet responsibility as well, I guess.